Paul Sokolowski. He did a wonderful presentation. See, you can come out to the observatory on a cloudy night, whether it's raining or snowing, and you can still learn something. And you learned a lot from Paul about our solar system, and now we're going to learn even more about what's happening in the universe and what you need to look for in the coming months. So I don't know if were any of you here on January 30th for our last presentation, open house? This is going to be like a continuation from there. We learned a lot last time, but now you're going to see how it all plays out. So if you weren't, it's all okay. You're going to learn a lot of new stuff tonight anyway. So here we are. Okay, here we are. We're the Harford County Astronomical Society, and we're usually here every 4 weeks, right around the first quarter moon. And we want to be here at that time so that when it is clear, you can look through our telescopes, see the first quarter moon, and then as the moon is setting, you can see other objects in the sky. So our next open house will be March 25th, and then 4 weeks from there in April. And if you want to know about us or see our presentations that are being filmed, you can go to hartfordastro.org, and we are here for you. And I want to let you know that as you saw with Paul, and we have a lot of members here in our astronomy group, our members know a lot about a lot of things. If you want to know about telescopes, if you want to know about observing, if you want to know which telescopes to buy as gifts, and they don't have to be very expensive. You can always count on our club to help you. And even if you did have a telescope, you didn't know what to do with it, you could bring it in here and our members will help you set it up. Our members are astrophotographers. I'll show you a slide of one of the photographs that one of our members took last open house, but a lot of our members here are experts at what they do. Always ask questions with them. Let's see if I can. Okay, let's hop to our moon. If you saw a little glimpse of the moon tonight, this is our moon tonight. It's a 5-day-old moon. It's only 2 days from the first quarter moon. First quarter moon is a 7-day moon, and the full moon is a 14-day. So we're working our way towards a full moon. This is a crescent, but it's waxing. It's growing bigger. After the full moon, the moon will start losing light and it'll be waning. So here, on our 5-day-old moon, this is the west. The moon is being lit in the west and it's growing this way. Now the opposite, 5 days from a new moon, is this moon here. If you want to see this moon, you have to get up a little bit earlier in the morning because we're past midnight already, and this moon is waning. It's getting smaller, heading towards the sun in the east. All right, there's a lot of things we see on the moon. Man in the moon, the woman in the moon. Well, there's also a poodle on the moon. And here's the poodle, okay? Now, in astronomy, you got to kind of use your imagination sometimes. And at the end of this talk, we'll have sort of a guessing game of the nebula. People can try to guess what the names of the nebula are. But for now, here's the poodle in the moon. And the nose, the feet, and everything. And they're all Maria. There's mountains on the moon, and there's Maria. Maria are flat plains, where when the moon was very young, it was very volcanic. And the lava came up, and it made a nice flat surface, kind of flat, and those are called Maria. And here's the poodle, right here. And we have the Sea of Vapor, and the Sea of Serenity, and tranquility, and crises, and fertility. So here's the poodle in the moon. Now, if you're looking for the man in the moon, these two would be the eyes, and then the nose and the mouth would be down here. But, you know, it's up to you. You look at the moon and you say, oh, I see a lion or I see a tiger. It's up to you. But this wasn't bad. The moon was a pretty good image. Now, next week, there's going to be a conjunction in the sky. A conjunction is when two things come together. They don't have to be physically close together, but you're looking at two objects in the sky that are coming closer and closer together. Jupiter and Venus will be the closest in the western sky about a half an hour after sunset. You don't even have to wait that long. Venus is very bright. You know how bright Venus is. And Jupiter is also very bright. So this is a good conjunction. So on March 1st, this is just a slide. This isn't necessarily Venus and Jupiter. But these two planets are going to be less than the width of the full moon apart. They're going to be very, very close together. It's going to be a really neat thing to see. Take your binoculars. That's all you need. If you have a telescope, that's fine. But you take your binoculars and just go out as the sun, just after the sun goes down, because the planets move very quickly to the western sky and they set. So if you go out about 8:30 or 9 o'clock, it's too late. So go out after sunset and start looking in the west. You'll definitely see Venus because it's our brightest planet. So it's Venus and Jupiter that are getting together on March 1st. I believe that's next Wednesday. So, okay, all right. Last in January, when you were here, we talked about comets, what comets were made of, and it was kind of cloudy on January 30th here. We saw the moon, we saw the southern sky, but the northern sky still had clouds in it, and we're waiting, because that's where the comet was. It was around the Little Dipper, Ursa Minor. So we're waiting for the clouds, and waiting, and then almost everybody left, except our astronomers here, our amateur astronomers, who would stay here till 3 in the morning if they had to. But about 9:30, things cleared up. And this photograph here was taken by that gentleman back there with the camera, Rick Finch. He's a professional photographer, and he does very well with photographing objects in the sky. And he took this photograph of the comet, probably pretty close to midnight maybe, but he did it. And we finally but this is what the comet looked like. It's greenish. It's greenish because the ultraviolet light from the sun attacks the carbon, C2 molecule in the comet, and it causes it to glow green. Just like the northern lights grow different colors, the ultraviolet light from the sun causes different molecules to make different colors in the sky. It's kind of a funny name, isn't it, for a comet? That's kind of a funny name. I made a mistake, and I admit it. I said that if you find an asteroid, they'll name it after you. Well, they won't. The only thing they'll name after you is a comet. If you discover a comet, they will name it after you. Everything else, the Astronomical Union has certain criteria for naming things. We'll talk about it in the future sometime. The planets go by certain names. The things on the planets go by certain names. The asteroids go by certain names. But this comet, C is for comet. All right, that makes a lot of sense. It was discovered in 2022 in March, okay? So March is the third month. ZTF was the name of the telescope. They had a name of the telescope. It's in Mount Palomar in Northern California. That's the telescope that first saw the comet. Now E, this is kind of funny. Every month has 2 letters. January is AB, February is CD, and March is EF. It was discovered in March, in the beginning of March, so it's E. And it's 3 because it was the third thing that was discovered at the beginning of March in 2022. So they have a funny way of naming things in astronomy, but some things are also simple, and we'll discover that later. I just wanted to wrap that up from last week, but it was neat. All right, let's talk about some things. Last open house, we talked a lot about hydrothermal vents, vents that come up from the bottom of the ocean and the animals and plants that live there, and why that's important, okay? Now here's Europa and Enceladus, 2 moons. What we're finding out now is that a lot of the moons in our solar system have water underneath their surface. Even our moon has water, and the poles. Mars has an ocean or a big lake underneath its north pole. And a lot of the larger moons in our solar system Jupiter's 4 Galilean moons, 3 of those moons have water underneath the surface. Enceladus is a moon on Saturn. It has water underneath the surface. Triton, which is a moon of Neptune, has water underneath the surface. And so probably does Pluto. And that's just amazing to discover something like that. And a lot of these moons have more water on them than the Earth does. That's a lot of water. Okay, here's Europa. What planet does Europa belong to?
Jupiter?
Yeah. What about Enceladus?
Saturn.
Saturn. Okay, we're going to talk about 2 of those today. Here's Europa, Jupiter, Enceladus, Saturn. This is what the top of the crust looks like, okay? And you can see here, there's a ocean, there's a salty ocean on the bottom of near the core of the planet. And then there's ice here, and the water, there's water here. And this is cool. I get to use my balloon this time. I forgot it last time, but I get to use my balloon. I can show you something. I'm getting older now, but I can still blow up a balloon. Now you wonder, well, it's cold out here. Why is there water? How can water be underneath a surface when it's so cold? Well, it's all because of Jupiter and Saturn. Jupiter is so big, and Saturn is so big, and the planets are so close to the moons are so close to the planets that this is what happens to the moons. Jupiter causes them to go like this. They vibrate, not a lot, but just a little bit. And just that little motion heats up the inside of the planet. And it causes the water to be water. It's icy water, and it's salty water, but it's water. It's not totally ice, okay? And what's happening here, I guess we can move on, and it shows it better there. But here's Europa. Here's Jupiter. This looks like it might be Io. Here, a little volcano coming out of Io. That's pretty neat. But here is Europa. This is what's happening. Down here, there's a hole. So the water comes. It's heated. This is warm on the inside. So the water gets heated, and it comes up as they call it a hydrothermal vent. It's heated water that comes up from the bottom of the mantle, below the crust. And it comes up through the ice, and it shoots out into space. There's fissures where the water shoots out. It's called cryovolcanism. It's not lava that shoots out, but it's water that changes to ice, and it shoots out. But down here, where the hot water comes up, it's close to 200 degrees Fahrenheit in some of the areas here. That's pretty warm. But it doesn't freeze because of the pressure. The pressure is so great that the water, even though it's hot, it stays water. And there's organisms that live on Earth. We have the same thing on Earth. Okay, hot water comes up through the hydrothermal vents. And there's organisms, there's a tube worm that lives down here. There's a crab. There's a clam. The crab is blind. They have no eyes because it's dark. They don't need eyes. Even on Earth, way, way, way down, next to a hydrothermal vent, it's nice and warm, and but the crabs don't need eyes. But I'll show you a picture of what lives down there later. But this is what's happening. This is why we want to send spacecraft out to Europa and maybe gather some of the vapor that's coming out of these vents. Maybe there's little bacteria in there, okay? Maybe something that'll tell us there might be life down underneath here where it's nice and warm, even though in order to really get down there, you're going to have to drill through miles of ice, okay? But that's what's happening on Europa. Here's Europa. Here's the icy crust, okay? Volcanic seafloor. This is where the hot water comes up, so it's nice and warm down here in the subsurface ocean. That's Europa's interior. Now, Enceladus is the same kind of thing. Here's Saturn, and Enceladus is here. Enceladus is doing the same thing. There's water vapor coming up through the ground, through cracks, through fissures, okay? And see this kind of like grayish area here? Those are all ice crystals that came up from Enceladus. This is the E ring of Saturn. And it's all icy particles from Enceladus, from doing this for years after years after years. And here's Enceladus, the rocky core, icy crust, water jets coming here, and the hydrothermal vents here, okay, in the global ocean. And some of these moons, like I said, have more water than on Earth, if you can just get down there. So here's Enceladus. On the South Pole, I believe it is, there's formations called tiger stripes. 1, 2, 3, 4. And there are fissures in the ground where geysers come up. And that's where that frozen water comes up and it forms the E ring on Saturn. But they gave them names. Okay, they named them Alexandria, Cairo, Baghdad, Damascus, and we all know those names as cities on Earth. Okay, that's they just decided to give them names. But look what it looks like. If you were standing on Enceladus, you would see one of these come up, and you want to sample that vapor to see if you can detect life. Once again, there hasn't been any life detected anywhere except on Earth so far. Okay, there's no Martians, there's no creatures walking on the moon, like that. I have some slides, but I didn't bring them, but they're not there. But anyway, this very exciting things happening out in space. And here's Enceladus. See, look at this is all shooting out into space. You got to get a spacecraft to fly down here and take a sample, because I think it's going to be a long time before something lands and drills down to get a sample of the water. But down here, there could be creatures living down there too. And these are some of the creatures that live in the hydrothermal vents on the bottom of our oceans where that hot water is coming up. You know, these creatures live 2.5 miles down under the water. And you can imagine what the pressure is like there. But the hot water, it doesn't boil. It just stays where these creatures are. Look how beautiful they are. They're really pretty. And there's bacteria that live inside here, and they help, they form the chemicals so that these worms can live. But those are real. Those are the ones on Earth. So we talked a lot about those last time. Okay, hey, did you know if you threw a 100-mile-an-hour fastball to the sun, it would take 106 years, 14 days, and 13.6 minutes to reach the sun? Okay, something to think about. That's how far away the sun is. If you threw a ball 100 miles an hour, it would take that long to get to the sun. All right, let's talk about Uranus. And I am glad that when Paul was here, the gentleman in the back said, when Paul pointed to that planet, he said Uranus. And that's the way you say the planet's name. It's Uranus, not the other one. So something happened to Uranus early on when the solar system was forming. Okay, this was a very active solar system. Jupiter and Saturn were going in and out. They were a lot closer to the sun than they are now. And Uranus and Neptune switched orbits. There was a lot going on here when the sun was first forming and the planets. And something happened to Uranus. See, our North Pole is right up here, maybe tilted a little bit, 23 degrees. Okay, but our North Pole is north. It's up and down. But Uranus's North Pole is here, North and South Pole. Early on in the solar system, something hit Uranus, maybe two objects hit Uranus and kind of tilted it. Okay, so it's almost 90 degrees. So everything revolves around, they don't revolve this way, but Uranus's equator is here. So the rings and the moons revolve around Uranus this way. Okay, everything is tilted on Uranus. So a lot of things happen early on in our solar system. So here's some of Uranus's moons: Titania, Oberon, Umbriel, Miranda, Ariel. Uranus has 13 moons, I believe. And Here are the names of the moons. Do you recognize these names from somewhere?
Shakespeare.
Yes, these are all names from Shakespeare plays and also Alexander Pope. He was either a writer or a playwright or something. These all contributed. See, Juliet, Romeo and Juliet, and Ariel. Ariel was a character in a Shakespeare play. It's very odd sometimes how the Astronomical Union chooses names. Sometimes they, well, let's have some fun. You know, it's not all serious. A lot of it is, but not all the time. Very good. Here's the rings of Uranus. There's 27 of them. And here are the moons. And more moons are always being discovered. Paul was talking about, what was it? Jupiter had 92 moons now? Am I saying that correctly? But number 92 is only 2 miles in diameter. You have to start asking yourself, what if the moon was the size of this coffee cup? Are you going to call it a moon, or is it just a rock in space? You know, that our telescopes are getting more and more powerful, and we're able to see smaller and smaller objects. So I think there should be a limit to what you call a moon and what you call a rock or an asteroid or something, you know. But anyway, this is Uranus. Now, remember how Uranus revolves. Okay, I say revolves. When the Earth turns on its axis, okay, once a day, that's rotation. When something goes around something else, that's revolution. So when the moons revolve around Uranus, but Uranus rotates on its axis this way. So if you were on a moon on Uranus, the sun's not going to go from east to west because you're facing the sun and you're turning this way. So the sun's going to go in a circle like this. It's going to be funny. It's just going to be you're facing the sun, but the sun's going to go in a circle, not east to west. It's a very strange place to be. Now, Paul.
The same side of Uranus always sees the sun.
I'm not sure about that. But maybe so. I think maybe so, because if Uranus is rotating like this, it can't rotate like this. So you're probably correct in what you say, just from judging on what we said. Now, Paul, before, I guess there's 2 camps out now. Is Pluto a planet, or is it not a planet? Paul likes his theories of, I'm going to stay with Pluto as a planet, and that's okay. But what's happening after Neptune? From Mercury to Neptune, the planets revolve around the sun like this, more or less, maybe a little bit of a tilt, okay? But Pluto is kind of like this. And most of the objects farther out from Pluto also revolve like this. All these objects have been discovered past Pluto. Okay, as far as our telescopes can see, that's a long way to go, 4 billion miles. So it's tough for our telescopes to see out. But here's Pluto, and Pluto had been the biggest, but Eris is a little bit bigger than Pluto. So now Eris is the biggest, Pluto is second. But all these different objects are discovered, and they have huge orbits. They go around the sun, way, way, way out and around the sun. Yep, quick question?
Why does, if I'm looking at that right,
This one?
Haumea looks like an egg somehow?
Why? Why? All right, you asked the question, now we're going to get an answer. Why would something that was spherical maybe become egg-shaped? Why?
Because like when it's orbiting around like the balloon thing.
No, it has to do with itself. What is it doing that makes it look more like an egg? It has to do with rotation. Because you know what that is, because I just told you. Rotation. It's spinning fast. When something spins fast, it kind of gets out of shape. Okay? And so it's kind of like egg-shaped, but it's spinning really quickly. And that's what happens. It's the same thing with Saturn and Jupiter. If you look at it, it's kind of squished this way. It's thicker in the middle than it is at North Pole and South Pole, because it only takes, about a half a day for it to rotate around, where it takes the Earth a full day. So it spins fast, so it's out of shape. But that's Sedna especially. It goes way out, way out into the Kuiper belt. And the Kuiper belt contains all the objects past Neptune. Okay, so you can say, well, Pluto is the first trans-Neptune object because it behaves more like these objects than it does the planets in our solar system. But you can decide for yourself. All right, did you know that the sun gets 7% brighter every 1 billion years? So how old is our Earth? 4.6 billion years old. So it's already 28% brighter than it was before, because the hydrogen is being converted to helium in the center of our sun, and it's getting hotter and hotter. But that has nothing to do with global warming. But we're talking about a billion years here, so don't equate that with global warming. That's just the future of our sun. Okay, let's do a little bit about the constellations. We talked about this in December. This is the winter diamond or the fall football. Okay, the diamond here. It's shaped like a diamond. Okay, this is Capella. This is Castor and Pollux of Gemini. Here's Procyon of the little dog. Here's Sirius, the big dog, or Canis Major. Here's Orion and Aldebaran here. Aldebaran is in Taurus, the bull. And here is the Pleiades, the seven sisters. Okay, but it's shaped like a diamond, and in the wintertime, it's right over your head. Right now, it's kind of heading towards the west, so we're saying goodbye to our winter constellations. Let's just talk about Orion a little bit. Here it is. Here's Orion, the hunter. There he is. Okay, here's his belt. We call it the belt stars, and his sword, shield, but that's how he got his name. Okay, and here are the names of the stars. Here's Betelgeuse. We'll talk about that. Here's Rigel, two big stars. Here's Bellatrix. Where have you heard that before? I know you all know, right? Harry Potter. Bellatrix means female warrior. And that's what she was in Harry Potter, a female warrior. It wasn't a very nice woman, but you have good guys. You have good guys and bad guys, And but that's Bellatrix. There she is. She's up in the sky, along with all her other friends. And we're going to talk about, this is where Orion's sword is and where Orion Nebula is. But here's Betelgeuse. It's a super giant red star. If it was where our sun was, it would come out almost as far as Jupiter. It's a huge star, okay? And it's only about 8 million years old. Our sun was formed about 4.5 billion years old. But the bigger the star is, it doesn't live very long, okay? And here it is. Look at how big it is compared to our sun. It's a huge red giant star. That's why it looks so big. It's about Betelgeuse is about maybe 450 light years away, or 650, somewhere around 500 light years away. And you know that a light year is 5.8 trillion miles, 1 light year. How far light travels in 1 year. Okay, and this is very far away, but it's still bright in our sky. Okay, and now what's going to happen to Betelgeuse? It could happen at any time, maybe between now and another million years. Nobody knows, but it'll explode. The same thing with our sun. It'll get so big, and then it'll run out of fuel. Our sun runs on hydrogen to helium in its core. Our sun's core is about 30 million degrees. So it's hot enough where 4 hydrogens become 1 helium. In here, we have a carbon becoming oxygen. Okay, it's millions and millions of degrees warmer there. But when the Betelgeuse finally explodes, it's going to be extremely bright. It's going to be brighter than the full moon, and you'll be able to see it at night and even during the day. Yes, do you have a quick question?
If the sun explodes, will we explode?
Well, to answer that question, first of all, it's not going to happen for about 6 billion years. So unless you plan on living a long time, you don't have anything to worry about. Okay, but that being said, what's going to happen is our sun is going to blow out to be a red giant. Mercury is gone. Venus is gone. Now, everything else is going to be pushed out, but it's still going to be too hot on Earth to live. Actually, in about 800 million years, all the water from Earth will evaporate into, it'll be too hot here to live. But the habitable zone is where the Earth is in our solar system's habitable zone, where water is water. It's not ice, it's not gas. That's why we're here, because our water can be water. It's not too cold, it's not too hot. But the outer planets, like Triton on Neptune, or some of the moons of Jupiter, might be just right for people to live, if there's people still around at that time. Now, when Betelgeuse becomes a supernova, look how big it's going to be. I mean, this is just really at night. But it's going to, first of all, it's going to become red. The color is going to change to red when it first becomes a supernova. Then it's going to be bright blue, and you'll be able to see it during the daytime. And after a few months, it's going to turn to orange, then it's going to turn to red, and then it's going to finally fade away. But you'll still be able to see it for about 4 years after the supernova. But it'll be a very unique sighting, because you'll be able to see it during the day, and it's going to be very bright. So anyway, here's Rigel. Rigel is the star on the bottom. Rigel is a blue giant, and if it were where our sun was, it would probably come out to Mercury. It's a triple star system, but it's all in a haze. It's very hazy, so these two stars are very difficult to see, if at all. And here's Rigel with the sun. It's bigger than our sun, but it's a blue giant. It's a blue giant. Now, let's look over here at this Orion sword. This is the Orion Nebula. This is part of the sword. And this is a place where stars are born. It's a nebula. It's all gas and dust, where gas and dust come together because of gravity, and they form little rocks, and the rocks get bigger, 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 and they form stars and then planets. Last time, in the center of that, there's the 4 stars called a trapezium, or 5, whatever it is. And we looked at that last time when we were here, in January. We had our telescope in the dome focused on the trapezium. It's right in here. But look at the difference of these two photographs. We talked about the spectrum last month, the ultraviolet, gamma rays, all the different types of radiation that's in our universe. But look at the difference. This is like a visible photograph, but this is an infrared photograph. That's why the James Webb Telescope is so important, because it can photograph distant objects in the infrared. And if infrared can see through gas and dust, I mean, look at the difference. All the gas and dust here, but the infrared, you can really see those stars. And that's what happens with a lot of nebula and faraway stars that the James Webb Telescope looks at. It's going to be a very good tool to looking way, way, way in the past. Here's the Milky Way. The arms of the Milky Way is a spiral galaxy. It has arms, just like the toy with the spirals, and the spirals go around the center. And each spiral has an arm with a name. This is a Perseus arm, Orion arm, Sagittarius arm, and there's a couple more. But here's our sun here, and here's Rigel, and Orion right here. We're close together, very close together. And that's why here's Betelgeuse, Orion's belt. That's why the stars look so big, because they're really not all that far away. Okay, they're our neighbors right here. They're our very close neighbors. Anything else in this one? No. But, oh, I got to interrupt again. I put this in the wrong place. Did you know that when the sun was first born, it had 10,000 siblings? Most of the stars in the sky are doubles or triples, as we see, okay? But our sun lost all its brothers and sisters. They just, through gravity or whatever happens, they go away. So our sun is now by itself. But when it was first forming, there was a lot. That blanket of dust that formed the sun also formed many more suns in the neighborhood, but they're all gone now.
And how do they know that? They can see that far back?
Now everything's from the Big Bang is, they're speculating from the way things look in the solar system, and they make theories about how stars are formed, about there's a cloud of gas and dust, and nearby there might be a supernova, and the supernova sends waves, gravity waves, and things start clumping together. And usually when there's a giant cloud of gas and dust, it doesn't just make one star, it makes a whole bunch of them together. And then they all go their separate ways. But here's our sun's closest neighbors. And this is 10 light years right here. So, within 10, 20, 30 light years, there's a lot of stars. I mean, our closest star to our sun, Proxima Centauri, is 4.2 light years away. And that's, just about this far away, right here, right next to our sun.
Has its own solar system too?
I'm sorry?
Do they think that has its own solar system?
Oh yeah. They're finding that a lot of the stars in the sky now have planets around them. Right now, over 5,000 other planets have been discovered around other stars, just by using our telescopes. Okay, and there's billions of galaxies. And galaxies can hold 100 million stars, 100 billion, 200 billion, 300 billion stars. So there's zillions of planets out there. Because usually when a star forms, there's leftover gas and dust. So then the sun starts spinning when things come together, like an ice skater. When the arms come in, they spin around. So when gas and dust come together, the objects they form spin around. And there's always leftover gas and dust from a star, so then the planets form. But there's a lot of stars that are very near our sun. Now, here's one that's 41 light years away. This one was recently discovered by Kepler that Paul mentioned. Now, this star is red, and it has 7 planets. Okay, there's these 3, these 2, and these 2. These 3 are very close to the star. There are probably a lot of volcanoes, hot, just like when the Earth was forming. Those 2. These 3, wait a minute, yeah, these 3 are in the habitable zone, could have water. Okay, and these 2 are so far away, it's cold out there, so it's icy. But here is Trappist-1, and here's our sun. It's a lot smaller, so it's cooler. Our sun is about 10,000 degrees Fahrenheit. Rigel, that you saw before, was about 20,000 degrees because it was a blue sun. And Trappist is about 6,000 degrees Fahrenheit. It's cooler. That's why the hottest stars are blue, white, yellow, orange, and red, just like the rainbow, from hot to cool. Okay, but these stars are dangerous. Well, here it is. Okay, these are probably too close to the sun. These 3, especially these 2, could possibly have water. These 2 are a little farther out. But the danger, most of the stars in the sky are red. I mean, well, the billions and trillions of stars, most of them are red dwarfs. Now, the danger of having a red dwarf star is it's very active. It shoots out a lot of solar wind with particles, UV radiation. A lot of radiation comes from these stars. And so these planets are, it's dangerous to live on the planets until the star gets older and it settles down a little bit. Okay? It's dangerous being close to a red dwarf star. This is what the habitable planets might look like. This could be water right here. We don't know. And there's the sun. You know, that's just an artist's simulation of what it might look like. And this is what the two inner planets might look like. This is what the Earth looked like 4.6 billion years ago. There was a period where Jupiter and Saturn kept switching their orbits. They go in and out, and all that junk, all the rocks and asteroids and comets that were left over from the planet formation started coming in towards the sun. And they all bombarded Earth and the moon, and this is what the Earth also would have looked like back then until that heavy bombardment stopped. It was a crazy period when our Earth was first forming. And it's a good thing we had a moon and we had Jupiter, because Jupiter and the moon deflected all those asteroids rather than them hitting the Earth. And if we didn't have a moon, we probably wouldn't be here. There's hundreds of reasons why we are lucky to be here. If you read the history of the Earth, there's a lot of things that happened where a lot of the plants and animals were destroyed and then they came back. Like when the dinosaurs were destroyed by the meteorite, then the mammals came up and we're here. So the Earth was a tricky place to live, and we are really very lucky to be here. All right, what do we got? So here, the Earth, it takes 365 days to revolve around the sun, 1 year. Now these planets, 1.5 days, 2.5 days, 4 days, 6 days, 9 days to go around the sun. Not 365, but they fly around the sun because they're so close. Even quicker than Mercury. Even Mercury is so close to our sun, it still takes 88 days. But these things whip around the sun. It's a very, very interesting solar system. But that's not the only one. There's many, many, many more. Now here's the fun thing. Our sun is yellow, yellowish white. It's considered a G2 star. It's a yellow dwarf. That means it's not huge. Polaris is also yellow, but it's a lot bigger than our sun. But our sun will last about 11 billion years before it turns into a red giant. And the bigger giant stars, they only live for millions of years. Our sun lives for billions of years. And those red dwarfs live even longer than that because they burn their fuel slowly. But if our star was a different color, see, you haven't a lot of you maybe don't know how photosynthesis works. Our leaves like carbon dioxide and they give off oxygen. We like oxygen and we give off carbon dioxide when we breathe. So we live together with our plants. We help each other. Why are the leaves green? Our leaves and our plants are green because the reactions inside the leaf use up the blue and the red light. They don't want the green light. So the green light is reflected off the leaves. But if our sun was a different color, our leaves might be a different color. There might be planets out there with a different colored sun where the leaves look like this. Okay, or the leaves look like this. It depends on how the leaves use the light. They might use up all the green. They want, say, I want green, so I'm going to reflect the red and the blue. They don't want blue. So things could be different on other planets. Don't think everything is always the same as it is on Earth. Funny things happen. Here's a good one. What if all our planets were black? Some of the blue stars use up all the light. So there's no light that the leaves don't like. So they're black. So you never, this is a giant blue star. So you never know what's going to be on another planet, what it's going to look like. We think that everybody's going to look like us, or all the creatures in Star Trek or Star Wars, you know, all the funny looking creatures. But the first things that are going to be discovered on other planets are the tiny little bacteria or those creatures that live at the hydrothermal vents, okay? That's my opinion, but I think that's what's going to happen. So anyway, different things can happen with different suns. Okay, here's a funny thing. There's a thing that's known as a cross-quarter day. A cross-quarter day are the days between the first day of winter, first day of spring, summer, and fall, and winter. Halfway between December 21st and March 20th is Groundhog Day. That's the halfway point. So when the groundhog comes out of this hole and he says there's going to be 6 more weeks of winter, technically he's right, no matter if the sun is shining or not. Because 6 weeks after here is here. It's the first day of spring. Okay? What the groundhog is telling you is what the temperature is going to be like. Is it going to be spring-like temperatures or winter temperatures? Okay, that's what the groundhog is really telling you. And May 1st, May Day, is the halfway point between spring and summer. Lamaz Day is August 1st, between summer and fall. And Halloween. It's not only Halloween, it's also cross-quarter day. It's halfway from fall to winter. Okay, so that's how dates have different names. All right, that's all I have. I don't want to keep you here all night. But we'll have some more next time. Good job. You guys are really smart. I'm very proud of you all. Good job.